Hello, everybody. So what we're going to be looking at today is the practice problems for midterm 3, which covers sections 5.3 up to 6.1 in your textbook. I forgot to change it in the PDF there. Yeah, your actual exam is only 5 questions long, multiple choice, so it should be pretty straightforward. I think we should just get right into it then. So problem 1 here says, evaluate the expression directly or exactly. Use a half angle formula. So in your cheat sheet over here, which I just have open in another tab, we have all of our identities, including the half angle formulas, and you'll find one for sine theta over 2. So you see sine, you write it. So I'm going to write out this identity, sine theta over 2 is equal to plus or minus. It's not actually plus or minus. It's you don't know if it's plus or minus until you solve the problem and figure it out for yourself. Okay. So this is the formula. And then what we've got going on is this. So the 112 is the theta over 2. So we have sine 112.5 should equal plus or minus, we'll figure out which in a minute, 1 minus cosine, and then it's cosine of what? Well, think about this. This is theta divided by 2. This is the small angle. This is theta. This should be twice as big. So if theta over 2, let me just write it up here. If theta over 2 is 112.5, then what's theta? Well, it would be double, right? 225. So this should be 1 minus cosine of 225 degrees over 2 in there, right? So that's the formula that we've got. And the idea here, I mean, of course, you can use a computer to help you with this, but if we want the cosine of 225 degrees, we should be able to get it straight from the unit circle. So I'll go over to my unit circle. I think we have one here somewhere. We'll find it. There it is. 225. It's down there in quadrant 3. And we want the cosine. And the cosine's the x value. So negative square root 2 over 2. So negative square root 2 over 2 over 2. Like that. So this is, again, plus or minus. We haven't talked about that. 1 plus square root 2 over 2 over 2. That's the value. This can be simplified. The easiest way to simplify it is if you do this. If you multiplied everything in the top by 2, and then if you multiplied the bottom by 2, then you wouldn't be changing the answer because you're doing the same thing to the top and the bottom. And if you do that, what happens is the 2 times the 1 is 2. The 2 times square root 2 over 2 is square root 2. And then on the bottom, 2 times 2 is 4. Which then you can, if you want, do the square root of the 4 and make it this. Plus or minus square root 2 plus square root 2 over 2. All right, so there we go. Now let's think about the plus and the minus. You do that based on the quadrant you're in. So this is the sine of 112 degrees. So where would 112 degrees be? Right? Just think about it. Just look at the angles you can see in the unit circle there. Right? 90 is straight up. I can't point on that side of the screen, but so like 90 is straight up, right? And then over to the left a little bit is 120. So where would 112 be? You know, somewhere there in quadrant 2, right? So in quadrant 2 here, the y values are positive and the x values are negative. And we're doing sine, and a sine is the y value. So in quadrant 2, the sign should be positive. So the sign should be positive. So sine plus, and the cosine, which we don't need, was minus in that quadrant. So what that means is it's not plus or minus here, just the plus. And so we could say that this is square root 2 plus root 2 over 2. Something like that. Okay, so that is how you would do that. Yeah, that's how you would do that. Now, problem 2 is actually pretty similar. If you look here, we've got a sine 2 alpha, sine alpha, and sine alpha over 2. So you have to use one identity for sine alpha over 2, actually the same one that we just used. You'll have to use one identity for sine 2 alpha, a different one, a double angle formula. And then for sine alpha, we're not going to have to do anything. In fact, if we look at this little triangle that we have here, you can see where alpha is. That makes this side the opposite side, and it makes the 8 the hypotenuse. And we know that the sine is the opposite over the hypotenuse. So we already should know that sine alpha is simply 3 over 8. So that one we can do with no identities or anything else. However, the other two, we're going to need trig identities for. And if you try to use trig identities, like for sine 2 alpha, you will look up the double angle formula there. Double angle formula. And it says that sine 2 alpha would be 2 sine alpha cosine alpha. And if you think about it, well, we do already know what sine alpha is. We did it right here. But we don't know what cosine alpha is. And in order to calculate cosine alpha, then you need to know this side of the triangle. So we have to do a little bit of work to find the third side of the triangle before we answer either of the two other questions there. So that's not that hard. We just, we'll do that with the Pythagorean theorem. So like a squared plus b squared equals c squared. So we're going to find that missing side. We have the hypotenuse is 8. The opposite side, which could be a or b, it doesn't matter. I guess I'll put it for b. The a we don't know. So we have a squared plus 9 equals 64. Subtract 9 to the other side. You're going to have a squared equals 64 minus 9, which hopefully is 55. And then that would make this side here square root 55, right? When you square root that to get a. So you get all three sides. Once you have all three sides, then you're able to go back and actually evaluate that sine 2 alpha, because we have 2 sine alpha, which we know is opposite over hypotenuse, 3 over 8, and then cosine alpha, which is adjacent over hypotenuse, so root 55 over 8. So what we get here is on top, 2 times 3 is 6, square root 55 over 64. And you know, you can simplify this a little bit, like you can cancel a 2 maybe, make that a 3, cancel a 2 there, make that a 32. Not a lot you can do there, but something like that. Okay. You just, where's my calculator in case I need it soon? All right. So, yeah, so we did that. Coming back over here to sine alpha over 2, well, that's going to be actually the same formula that we just used in the previous problem. So sine alpha over 2 will be, according to the half angle formula, plus or minus square root 1 minus cosine alpha over 2. This is a triangle, and on a triangle, the sine and the cosine and everything should be positive. Also, alpha over 2 is even smaller than alpha. There's no negative numbers here, is what I'm getting at. So let's just take away the plus minus now, and we should just be able to fill this out. So square root 1 minus cosine alpha. Cosine alpha is root 55 over 8 over 2. And again, you can simplify that a few different ways. I could multiply by 8 over 8 in there, similar to what I did on the previous one, in which case I would get 8 minus root 55 over 16. And I could turn that into square root 8 minus root 55 over 4 if I do that square root of 16. So I guess that's what I have. And that's it. So that's a little bit, I wanted you to practice two different identities there. You have to look up the correct identity and then apply it correctly using that triangle. And in order to use the identities, you did need to know what this third side was. So you just calculate it with the Pythagorean identity first. Okay. So this is one of these questions. There was a similar one on the previous exam, or maybe the previous practice exam, where there's a big long description of a problem, and then the point was not that you didn't actually need to think about the word problem. It's not actually a word problem. So what this says is that this is going to be a way to calculate this guy throwing the shot put, and it ends up landing here, and this is a certain distance, and you can calculate the distance if you know how fast he threw the shot put. Then you know, and you know the angle, then you know how far the shot put's going to go. Okay, so that's what it's saying, but we aren't being asked to do anything with that formula, really. What we're being asked to do is use an identity to express the formula so that it contains the sine function only. Hint, look at an identity with sine theta, cosine theta, because this has a sine theta, cosine theta. And so what you are supposed to do here is this. So you look at all your identities and you'll find, hopefully, the double angle formula. So you see sine 2 theta is 2 sine theta cosine theta. So we know this, right? So this is a double angle is sine 2 theta equals 2 sine theta cosine theta. Now, if I just move the 2 over to the other side, you don't have to, but this makes it easier. If you do that, then you can write it sine theta cosine theta is sine 2 theta over 2. Does that make sense? So you have this. That's just moving the 2 over on the double angle formula. But then, if you look at this, we have a sine theta cosine theta right here, right? So if you just use this little identity here, let me see if I can move it. If you just use this identity, and you, I lost the cosine. If you take this right here, matches this right here, so we should just be able to replace it with sine 2 theta over 2 and write V naught squared over 16. And then the part in the pink box, we can now write sine 2 theta over 2. And that's it. That's all you're being asked to do, is make a substitution here so that we only have a sine. So we did it. And that's done. So then we just write our answer here. I can combine the 2 with the 16 and write this as V0 squared over 32 sine 2 theta. So that's it. So we weren't, solving any complicated equations or anything. We were just replacing the part here using an identity. All right, next question. Find all solutions of the following equation in the interval 0 to 2 pi. Write your answer in radians. So on one like this, where there's only one trig function, you use a little bit of algebra to isolate the trig function. So 4 tangent squared x minus 2 equals 10. So what do? We're trying to get the trig function by itself. So add 2. You get 4 tan squared x equals 12. Divide by 4. You get tan squared x equals 3. You square root. So we add a square root here, add a square root here. But when you square root, you end up having to pick up a plus or minus. So you get tangent, nope, not tangent squared because we're square rooting it. Tangent x is plus or minus square root 3. Okay, so we get here, and then the idea here is this is where you would look at your unit circle to figure out where this happens. Okay, so on the unit circle, this unit circle over here is not that good to look at, but when you see like tangent is plus or minus square root 3, well, we don't list the tangent on the unit circle. You know that the you should know that the x value on the unit circle gives you the cosine, and the y value gives you the sine. And so just to help you think about it a little bit, think about it this way. So I know that the tangent on the unit circle is, well, it's the sine theta over the cosine theta, right? And we know that that is supposed to be a square root 3, right? Or plus or minus square root 3. But if you think about it, the only place a square root 3 is going to come from is from like the angles that are like pi over 6 and the angles that are like pi over 3, right? Like, you can see the square root of 3 there, and then you can see the square root of 3 there. But if you mentally do this, or even not mentally, if you use a calculator, if you do 1/2 divided by square root 3 over 2, what ends up happening is you get this, 1 over square root 3. If you do it square root 3 over 2 over 1/2, upside down, that's how you get a square root 3. So when you're looking at the unit circle, in order to get a square root 3, we want the square root 3 over 2 on top. And we know that it's sine over cosine. So specifically, we're going to be looking for places where the y value on the unit circle, which is the sine, should be the square root 3 over 2, and the cosine, which is the x, should be the 1/2. I know that it has to be the 1/2 and the square root 3 involved, but we specifically want the square root 3 on top. Otherwise, we would end up with 1 over square root 3, not square root 3. And we're supposed to get square root 3. Okay, so, I mean, there was some explanation for that. If you look at the unit circle then, what we're going to be ending up with is at pi over 3, that's one place where you're going to have 1/2 square root 3 over 2. On the opposite side down here, there's another place that's going to be 4 pi over 3. Where you have negative 1/2, negative square root 3 over 2. That's what would give you the plus square root 3. But then for the minus square root 3, there's going to be two more. One up here and one down here. Because there's another angle where the y value is square root 3 over 2. It's 2 pi over 3. And another one in the bottom right, which is 5 pi over 3. And all of those have I didn't write it here, but like negative 1/2, positive square root 3 over 2. The one down here is positive 1/2, negative square root 3 over 2. But they all have the square root 3 as the y value, and they all have the 1/2 as the x value. So when you put the y value over the x value to calculate the tangent, you're going to get a square root of 3. The only difference is sometimes you're going to get a plus and sometimes you're going to get a minus depending on what the signs are on the y and the x. So you do all that work, we look at the unit circle, and the 4 places that I just boxed there, those are the angles where you're going to get that square root 3 for the tangent. Tangent is the hardest one, right? But so what do we have? Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So quite a few of them, 4 answers. If it was a sine or a cosine, this would have been much easier, right? Because you can just look and see the sine and the cosine on the unit circle without having to think about dividing things like we did here. Okay, so those are the solutions. Next problem. Yeah, so this will be an example of, an easier version of this problem. Find all solutions in 0 to 2 pi. Write your answer in radians. So we'll redo the process we just did, but it'll just go a lot faster. So what do? You need to get the cosine by itself. So easiest way here, I'm going to add it to both sides. That just will make everything positive. I like that. 1 equals 2 cosine theta. So then you would divide both sides by 2. 2, 2. So we end up with 1 equals, we end up with 1/2 equals cosine theta. And then we just look at the unit circle to see where you end up with a cosine of 1/2. And so remember that remember that the cosine is the x value. So we're looking for the x value to be 1/2 on the unit circle between 0 and 2 pi. So we just go around the unit circle and we look for an x value of 1/2. So where's the x value 1/2? All right, here's the first place, pi over 3. Keep going. X value of 1/2, not 2 pi over 3, right? Because that's a negative 1/2. We don't have a negative here, and there's no plus or minus. Down here, we see 4 pi over 3 gives you an x value of negative 1/2, but that's negative again, still doesn't count. And then over here, I see 5 pi over 3 has an x value of 1/2. So that's the other place where the cosine will be equal to 1/2. And that's one full revolution between 0 and 2 pi. And so we're done. So when you don't have a tangent or something, a much simpler problem when you get to the point of looking for your answers on the unit circle. Okay, another one. Man, why'd I put so many? Just practice, I guess. Okay, so find all solutions, write your answer in radians. Okay, so this is very similar to what we just did, so hopefully we can do it pretty quickly. The key here is understanding that when you multiply two different things and you get 0, what that means is that the first thing is equal to 0 or the second thing is equal to 0. So when you see this kind of an equation, you need to split it up into two equations and you say, well, either sine x minus 1 is going to be equal to 0 or 2 sine x minus 1 is going to be equal to 0. And these are just two separate equations now that you just have to solve. So you solve that one, and you solve this one, and each one of those is just like what we just did on the previous problem. So they're not, they shouldn't be super hard, but, you got to do them, right? So we solve this. So you just move the 1 over, sine x equals 1. On the unit circle, you're looking for the sine of the angle is 1, and we know that that's going to be the y value on the unit circle, right? That x right there is not referring to x on the unit circle. That x is the angle, right? They can use whatever variable they want there. So even if it's confusing when they use an x, they can still use an x. So sine x is the y value on the unit circle. So where is the y value equal to 1? Well, you just look at your unit circle. Where is the y value equal to 1? And there's only one place, up here at the top. Right? That's where the y value is 1. So the angle is pi over 2. Okay? And that's half done. So now you have this one we need to solve. So 2 sine x equals 1. When I move the 1 over, divide both sides by 2. Sine x equals 1/2. Again, on the unit circle, this is the y value. So we want to know where is the y value equal to 1/2. That's very similar to what we did on the previous problem, but we're looking for a y value of 1/2 now. So where does that happen? First place we see with a y value of 1/2 is angle pi over 6. And then going around the unit circle, we find another one over here, 5 pi over 6. And that's it. There's others, right, that have, you see a 1/2 for the y value, but they're negative 1/2, which is not what we're looking for. So put this all together, and the answers that we get are pi over 6, 5 pi over 6, and pi over 2. 3 answers. Okay? So, yeah, I mean, kind of similar problems. The one where we had to deal with the tangent, that was the hard one. Okay, and then we get into our law of sines. Law of sines to help us find a triangle. So, what's the law of sines? Well, hopefully you guys watched the lectures or you watched the Zoom hours that have been recorded. But basically, law of sines is like this. Let me see if I can write somewhere. So, law of sines deals with triangles where there is no right angle, typically. So there's just an angle A, an angle B, and an angle C. And none of them are 90 degrees. So your regular trig doesn't work here, right? Like this is not the same as problem 1, I think problem 2, right? Problem 2 has a right angle right here. So you don't need like law of sines to do this. But this one is just a generic triangle where the angles can be anything, and your regular trig is not going to be too helpful here. So what we do is your angles are ABC, and then we label the sides also ABC, but lowercase. And you need to make sure that you do it this way. So like angle A is here. It doesn't matter where you put the A, B, and C, but wherever you put the A, angle A, across from that, that's where side A is. So this is side A. And this is angle B, so across from that should be side B. So side B should be down here. And here we have angle C, so across from that should be side C. Right? So that's the picture. And then what the law of sines says is this, law of sines. 2 forms of it. One is sine A over A equals sine B over B equals sine C over C. Or you can flip that upside down and have A over sine A, B over sine B, C over sine C. All right, and so in a problem like this, they're giving you 3 of the things and they want you to calculate the other 3. So I always start a problem like this by writing ABC and little a, little b, little c. I fill in what we know. So C is 82, B is 54, and then we have little a is 16. So that's what we know. And then we need to figure out the rest. Okay? So the first thing you can do, I didn't write it up here, but keep in mind this is a triangle. So a property every triangle has is that the angles add up to 180, right? So like the A and the B and the C need to add up to 180 degrees. So the way you would use that here is you notice that you have 2 angles already, right? So if you've already got 2 angles, you can calculate the third because they have to add up to 180. So your first step here would be get A from A plus B plus C equals 180. Or easier way would be A is going to be 180 minus the other 2. So 54 and 82. So you figure that out, just grab a calculator, 180 minus 54 minus 82, and I get 44. So that's what we need to make these add up to 180. It's easy to verify that. So we are 1/3 done. Okay. Now, whenever you know two angles, you always just calculate the third the way we just did. So then what we need is a way to calculate the little b and the little c. So here's what you do. We know these two now, and we know the b, and we could calculate this b using the law of sines. So you take the law of sines and you just take the part that will have what you need. So I'm only going to take the a and the b. I don't need the c right now. So what I'm going to do is I guess I'll do it right here off to the side. So what I'm going to do is I'm going to find b with law of sines. So I write out part of the law of sines. I took the second form, by the way. I took this form instead of this form because I'm looking for little b right now. And I don't want little b to be in the denominator if I'm trying to find it. I would rather it be in the numerator. It'll be easier to do the algebra. So that's the reason I'm taking this form and not this form. What I'm looking for should be in the numerator. So a over sine a equals b over sine b. So you write that out, then you fill in the numbers. Whatever numbers you have. So the little a is 16. Big A, I think we just found, is 44. Little b, we don't know, so we just leave it little b. And then big B is 54. Okay? So this is what the law of sines tells us, and then you just want to solve for the b. So all you got to do is basically take this sine 54 and we will move it up on the other side. And we have b equals sine 54 times 16 over sine 44. And we just go to like Wolfram alpha or something to calculate this. Be careful here. A big problem people will have on this is that we're measuring these angles in degrees, and you need to make sure that your calculator is in degree mode, or that Wolfram alpha actually uses degrees. So I'm going to type this in twice to show you something. So sine 54 times 16 divided by sine 44. Now, if I type this in, this is going to be the correct answer. And I know it did the right thing because see the degree symbol in my input? It says sine 54 over sine 44. So I have b is, scroll down here, decimal version, we'll say 8.6 will be good enough for us. Okay? Now, the reason you have to be careful is if you had decimals, like if I come up here and I put in, let's say like 44.1, I can't put the cursor where I want it. Hold on a second. All right, I'll just have to type it in. Like 54.1, if you type in a decimal like this into Wolfram alpha, then if I hit enter, look at the difference. No degree symbol. So Wolfram alpha did not know that I wanted degrees here. And so it calculated the wrong answer because it's trying to do it in radians, even though my angles were supposed to be in degrees. Of course, I mean, it wouldn't be right anyway because of the decimals. I put in the wrong numbers. But so what you have to do with there is if you have decimals, make sure you tell Wolfram Alpha you're using degrees. So you could do it this way. It looks a little silly to type it in this way, but if you say the word degrees, then it knows you mean degrees. Okay, so just be careful how you type it into Wolfram Alpha, or if you use a calculator, your calculator must be in degree mode if you're using degrees. Anyway, so we have B, 18.6. I'm just using one decimal place here. And then we need C. Well, how would we do C? Well, we do it the same way. So you go back up. We have the law of sines. Hey, what happened? So we have the law of sines again. Except if we're calculating C, we don't want A and B. We want B and C. So I'll just change these A's to C's. And you might say like, well, why are you using B and C and not C and A? Well, I could use C and A, but the reason I don't want to is because, oh, actually I do want to. What I don't want is, I don't want the one that I had first. I don't want this. The reason I don't want this is because if I use this formula, I'm going to be plugging in 18.6 for my B. But where did the 18.6 come from? I calculated it, right? That means this could be wrong. If I did a bad job, this could be wrong. So I would rather not use the B because the B was from me. So like if I have a choice, I would rather use the A and the C because the A came from the problem. So this is right. This could be wrong if I did a bad job. Does that make sense? So if I have a choice between using A and C or B and C, I'll choose A and C. Theoretically, it doesn't matter. Just increase the likelihood of getting the problem right. Okay, so I'll use A and C here. Again, fill in the numbers that you know. So what do we know? We do not know little c because we're looking for little c, I think, aren't we? Yeah. But we do know big C is 82 degrees. And we know that little a is 16. And we know big A is, I believe, 44. Yeah. So just like we did for calculating the B, you fill in the numbers that you have. And then if you're looking for C, C is going to be the 16 over the sine 44 degrees times, we are going to be moving this over to the other side, sine 82. So you type that into your calculator. Sixteen divided by sine 44. And again, you don't have to, but I could type degrees. And then times sine 82. I should not have to type it in again, but I will. Degrees. You verify that this is, what you want, right? I typed it in correctly. And then my answer is 22.8. And that's it. So that's how I would use the law of sines here to find those missing sides. Okay, so that is the law of sines. Okay. Now, the remaining, 2 out of the 3 problems that are left, actually, hold on, let me look. Actually, this is really the end of what is actually being tested on. So 8, 9, 10 are not actually on the exam, okay? But I'm still going to do them anyway, but this is not on the exam. Okay. But this is just a useful formula here. So what it says is normally you might remember from geometry, like in high school, from high school, that if you have a triangle, just kind of a general triangle here, then you have like a base, and then you have like a height, and then the area of a triangle is 1/2 base times height. You probably remember that. But what if you don't know the height, right? What if you have a triangle and what you know are an A, a B, and a C, and a C, a B, and an A? What if you just have this? You don't know the height. No height. How do you calculate the area? Well, there's two different ways to do it. So one of them is we do in problem 10, and one of them we're going to do here. So no height, no problem. We can use this formula. So, oops, that should be area. So we could use area is 1/2 AB sine C, or 1/2 AC sine B, or 1/2 BC sine A. Any of them. Okay, so any of those formulas would work. And so again, I try to use the numbers that they gave us more than the numbers that we came up with, but we're not going to be able to completely because of the because we had to calculate too many of the numbers. But we can do this. So which one do we want to use? It doesn't matter. Let's use A for sure because we calculate like they gave us A. So let's just use this first formula, I guess. So and it says to calculate the area from the triangle in the previous problem. So the triangle that we just did. So let's just use that first formula. So we have 1/2 A. A is 16. B is 18.6. And then sine C is angle C, 82 degrees. There we go. So we should just punch this into a calculator and it will give us our area. So 0.5, just being lazy, times 16 times 18.6. And yeah, we rounded, so this isn't perfect, but it's good enough. Sine, I'll put multiplication sine 82. And again, I can type in degrees if I'm worried about Wolfram Alpha not understanding. So 0.5 times 16 times 18.6 times sine 82. Result 147. Yeah, we'll say 0.35. That's the area. 147.35 units of area, right? We didn't have units, so there we go. So I just kind of wanted you to see a formula for area, even though this is not on the exam. So you can calculate it without knowing the height. But, it's a more complicated formula. Okay, next question. Use law of cosines to solve the triangle. So the law of cosines, again, the setup is exactly the same in terms of ABC. I'm not going to draw the triangle, but I am going to write the law of cosines for you. This is also not on the exam. No law of cosines. But here's what the law of cosines says. So 3 versions of it. So one says a squared equals b squared plus c squared minus 2 bc sine a, something like that. And then we have variations of this with the letters moved around. So b squared would be a squared plus c squared minus 2ac sine b, and c squared would be, I guess, a and b minus 2ab sine c. Okay, and so you can just look those up, of course, in your textbook if you want. Section 10.2, law of cosines. Scroll down a bit to where they just give them to you, and there they are. They call the angles alpha, beta, gamma instead of A, B, C, but there you go. This should be exactly what I wrote, and they are. So, and then there's your picture, just the same generic picture of a triangle. Okay, so that's the law of cosines, and you use it when you can't use the law of sines, basically. If you write down like the information for a particular problem, which I always do, I always start by writing this. Fill in the numbers we know from this triangle here. Let's see what we know. C is 8. B, angle B. Oh, oops. That C is 8. Angle B is 32. And then little a is 6. Okay. Now, if you think about it, we know an A, a B, and a C. But we don't know A and A. We don't know B and B. We don't know C and C. That's different than the previous problem, right? We started out knowing these two that went together. Yeah, we had two that went together, an A and an A. And if you have like an A and an A, B and a B, or a C and a C, then you can use law of sines instead of law of cosines. Because law of cosines, the formula is a little bit more complicated. So when you have an A, a B, and a C, nothing goes together, then you're going to have to use the law of cosines to get one of these. It doesn't even matter which one you do. You can get the A, the C, or the B, just depending on which one you feel like doing. I think I'm going to get the B from the law of cosines. Okay, so I'm going to get the B, little b. So I will take my law of cosines, the one that has the little b by itself. That's going to be the most convenient form. Okay, well, I just lost it, but let's just back that up. Duplicate that. Let's just go down here. I'm just going to go to the bottom of the page where there's room. Okay, so I'll use this form, and I guess I'll just copy this to duplicate. Actually, we don't even need to look at the triangle. I'll just do the whole thing down here. Okay, so here's what we have, right? So I want this form of the law of cosines because I'm looking for b right now. I just decided I could have done the others, but I'm looking for little b, and little b is pretty close to being solved for. So that's why I used this version of the formula. So I use this version of the formula. Also, if you look at what angle you have, the only angle we know is capital B. So I actually had to use this formula because this one has capital B in it. I still didn't have to. I could have used the others. I could have used the others to find A. But I didn't. Okay, so I'm using this one. This is the one that makes sense to start with. So you fill in the numbers that you know. So we don't know B. We're looking for B. But we know little a. We know little c. And then we have 2, a, c, sine B, which is 32 degrees. Okay, so all of this, that's just can be typed into Wolfram Alpha or a calculator. I'm just going to use a calculator because it'll be a little bit faster. But I'm just going to literally, oh, actually I'm not, because I don't know. I don't want to remember how to, I don't want to take the time to put it in degree mode. So I'm just going to do this. So everything on the right side there, I'm just going to type into Wolfram Alpha. So 6 squared plus 8 squared minus 2 times 6 times 8 times sine 32 degrees. I'm going to type it in, even though, again, it doesn't matter here because there's no decimal, so Wolfram won't screw it up. But I type it all in, verify that I typed it in correctly, and I get 49.12775. Okay, now that's not B, that is B squared. So if I want B, I have to square root this. Okay, easiest way is just to type it in again. Just clear this. So I want the square root. So square root 49.12775. That's more decimals than we need, but it doesn't hurt. 7.009. Probably 7 is good enough, right? But we'll carry it out to a few more decimal places. Doesn't hurt. So I've got little b. 7.009. Okay. Now, as soon as you have two things that go together, the b and the b, we can use law of sines to calculate the capital A and the capital C. So once you use law of cosines once, then you're going to have two things that go together, and you can switch to using the law of sines, which is simpler. So now we'll use law of sines to calculate, let's say capital A. Why not? Capital A. Okay. So then what you would use to calculate that is, well, we're doing law of sines now. So we'll use the b because we know the b's, and we're calculating a, so we use the a. So the version that we want of law of sines will be this one, sine a over a, sine b over b. Now notice that this is upside down compared to how we used it last time. And the reason it's upside down is because this time I'm looking for an angle. I'm looking for capital A. So remember what I said a long time ago. We used this one when we were looking for the little a, the little b, or the little c. But if we're looking for capital A, capital B, capital C, you use the top form. And then again, you just use whichever one you want to, as far as this one, this one, this one. So I will use, where are we? This version, because we know the B and we're looking for the A. So you write that form down, fill in the numbers. So we have sine A, we don't know A. We know little a is 6. Big B is 32. And little b is 7.009. Again, we could have called it 7. Okay, so then that tells me that sine A is sine 32 degrees over 7.009 times 6. Right? We're just gonna do this, right? We're just times 6 times 6. So what do we do now? Well, we have sine A, and then we have something we can calculate on the calculator. So we have sine 32 degrees divided by 7, okay, 7.009 times 6. So you type that all in. Notice that I didn't type degrees, but it did understand degrees properly. I see the 32 degrees, and it tells me that my result there is 0.43633. Okay? Now that's not A, that's sine A. So if you're trying to calculate A, then what you need to do is take the inverse sine of both sides. Why did I write 4.3? That should be 4.5, right? Wait, I just wrote that wrong. It was 4.53633. 4.53633. Okay, so I need an inverse sine to calculate that. So come back up here, and I'll type arc sine 0.45333. It will give me my answer in radians and degrees. I want degrees to match everything else that we've been doing. So 26.98 there. Degrees. Okay. And, when we go up here, maybe what we should have done is just said, like, maybe we should have just called that 7. And when we do this one, 26.98, maybe we just call that 27. Right? That makes sense. Just round it. Like they're so close to being whole numbers, we might as well just round it. Okay, so we have those two. And then for the last one, for capital A, which we're still missing, you could use law of sines again. But don't. Why not? Well, remember, the angles add up to 180. So if you know 2, you don't need to calculate the third with a complicated formula. We know that they have to add up to 180. So instead, just say that A has to be 180 minus the other 2. So minus 32 minus 27. So that's a lot faster than law of sines. So we type them all in, we get 121. Okay, so we have them all, and that's what they mean when they say, when they say solve the triangle, they mean find all of the angles and sides. So we did that. So I'm just dragging it all up here. Put it here. Okay, so we found them. So the little b was 7, the big C was 27 degrees, and the big A was 121 degrees. Okay, that's it. So, sorry, just thinking about this a little bit. I think, hold on. There must be a small mistake here. If A is 6, which it is, and if C is 8, which it is, then I feel like big C needs to be bigger than 27. Where did we calculate big C? Oh. Oh. Okay. Let's go back here and not be as stupid. We calculated law of sines to calculate A. We did all the work. We got 27, and I wrote it here. But that's here. That's A. So then when I said for A, since I wrote the A in the C spot, we calculated A again, but that should have been C. 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 So I had the spots reversed, right? 121 degrees. Okay. So this is all wrong. Just the A and the C are backwards. I was looking at the picture and I was like, that doesn't look like it could be correct. Lost it. Sorry. Sorry again. Okay. All right, so let's put them in the right spot, right? So actually, the C is 121 and the A is 27. Okay, so we just reversed those. Sorry about that. Okay, finally, last problem. So this problem here is another way to calculate an area from a triangle when you don't know the height. Okay, so like what you've got going on here is you've got some triangle. I'm not going to label it appropriately. Like, I don't care about accuracy in the picture. So like, let's just say 4, 5, 7. Okay, so there's a triangle. And we don't know any angles, right? The previous area formula we used here, you needed an angle. Well, I didn't give you an angle here, but it actually turns out that there is a way to do it without knowing the angle. And how do you do it? With this formula, which is called Heron's formula. So this is also not on the exam. Just wanted to give you a formula. You know, maybe this is useful. You can remember that it exists later on when you're trying to calculate the area of a triangle. Okay, so how does this work? So you have all three sides. It doesn't matter which one's A, B, and C, but one of them's A, one of them's B, one of them's C. So it's a two-step process. So the first step is to calculate this thing that we called S. Okay. So step 1, compute S. So S is 1/2 of A plus B plus C, which is 1/2 of, it says 1/2 of the perimeter, so we just add it up. 1/2 4 plus 5 plus 7. That's it. So 1/2, 4 and 5 and 7 is, 4 plus 5 is 9, 9 and 7 is 16. So 1/2 of 16, so it's 8. Okay, so S is 8. That's not the area, that's just S. Okay, and then once you have the S, then now you can go and you can use this formula to calculate the area. So part 2 is compute area. So the area is, it says, that's area, not, you know, capital A from before. Area. So it is S, S minus A, S minus B, S minus C. So you just fill in the numbers now. So it is square root, S is 8. So 8, 8 minus, and then each of the sides. So 8 minus 4, 8 minus 5, 8 minus 7. And so we just put that into a calculator. So we got square root 8 times, and I'll just do the subtraction. So 8 minus 4 is 4. 8 minus 5 is 3. 8 minus 7 is 1. So we get 9.79, or if we round, 9.80. Okay, and that's it. And so simple process, 2 steps. And you don't have to do that on an exam or anything. It's not on the homework. I just kind of wanted you to see that these formulas exist in case you're ever, trying to calculate the area of a triangle. And all you can remember is, I don't know what I just did there. Um, you might just remember this formula, but there are other formulas for areas of triangles if all you know is the sides, like we do on that last one. So it's just neat that the formula exists. Yeah, just neat that the formula exists just from the sides to the area. Okay, well, anyway, that's it. So good luck on the exam. And yeah, that's about it.